Alex from Blue Lightning Software again. Disclaimer, I've not really done this much before at all. In fact, I have used other people's entity things in Unity and it was okay, but I've not actually written anything myself. So this could be an interesting test, right? To say, hey, this is how easy it is to get into dots and the job within Unity, iJob. It's complicated it's not complicated. Okay, it's a struct that inherits iJob. The only thing of iJob, right, is this execute. You have to have a public void execute with anything you want in it. You know, this was how it came. If you know, this makes it an iJob and it compiles, right? You can see that. If I didn't have this, it would complain. Complexio does not implement iJob execute. So this makes it a job, yeah, an iJob. The rest, these are inputs, okay. At this stage, I'm using native array for everything. There's kind of a scheme within the job system of Unity that is saying everything has to be a native array, so that because it's passing between Unity's native code, unmanaged native code, and your managed C#, yeah, via these native arrays. So that's native array. Understand, a native array is just a type inside a native array. I think of it as just an array of integers described as a native array, yeah. And this is the float. Now I'm using these to pass in, hold on, let's rewind, there we go, to pass in this as iteration 0, right, in case I change them, and complex factor 0. The fact that they're read-only means they can be used by all of the jobs simultaneously. How that adds up, there's a couple of ways of doing it. Okay, there's just iJob parallel 4. This, okay, now this runs slightly differently. Execute int. All right, now what that does is it has like an indexer to these arrays that you can pass in. Okay, I need to read a bit more about it. I've really launched into this. This is going to be a very that is where the true power, I think, of the job system lies, is within those parallel 4s, in that it will loop through native arrays, okay, and so that you can send in arrays of the same things that are going to do the same things. The execute is kind of executing the same task on each of the items of your native array. Okay, I think you pass structs into this, all kinds of stuff. I've got to check it out. Anyway, that's the most basic form of a job. I would probably need a pause between videos to kind of, you know, because it's streaming live, I'd have to go and check how exactly to do that. But the output, if there was an output, all right, because we're just doing this to time it, it is kind of non-consequential. Let's go. How we got? Is this streaming? Like, we can check. Check your own stream. Yeah, I think I am. Yeah. Okay, that's it. All right, so it's coming straight out of the manual. Complete all. Where's the right page? Here we go. This page here in iJob can practically tell you everything you need to know for this. All right, so let's have a look at this. The docs, Unity 3, 22.3 that I'm using, the current LTS. This is the manual with regards to jobs, unity.jobs. So let's have a look. Here's an example one: struct position, execute, can access those things, and it loops through them in this example. And then update of a thing that's looking at these, var job equals new job. So what I wanted to do, I'm going to hack apart the test stuff now, because what I'm going to say is that the invoke, I'm going to use the invoke just to get the timing. There is a way to schedule batches of jobs, all right, but I'm not 100% sure how that works even at this point. And if I would use it for this, what I'm going to do is replace complexio there with inside the invoke method with some code that we're just going to cut and paste from here. Hopefully, tell me you can cut and paste from a Unity manual page. Yes, here we go. So we've got a var job. Alright, so that's our job. And what have we got on ours? I really should just learn to code. Here's, oh, right, anyway, because I'm stupid. Does it need everything to begin with? Complex factor. Oh, wow, yeah. Do you know what the best way to do this probably is to set these. This is worth knowing about. And I'm going to do this at the start of invoke test. Okay. What does this do? So we go to invoke test. Before it starts, I'll even do it part of the stopwatch. It creates two var position and yeah, don't like that. Might be. So we've got an int of 1 and a float of 1. I always need a template like this. So we're going to have a native array float. We're going to have these here. We're going to have this one here. This one's the complex factor. Is like local to the object of the test object. Okay, so this is iterations. Yeah. And we just create them here. And we create them like that, and like this. Alright, but this one's a float. So what's important there, it's persistent. Yeah. Alright, this is judged from a superficial reading of the manual, the way. This is what you need to have: an allocator type, alright, for your native array. And there are different types: one use only, first one none. Where are they? Temp job, temps, they call them temps, temp jobs. That's like if you want to use them for 1 or 2 frames, you would pick one of these. If you want it to be persistent, i.e. don't destroy it every frame, or don't expect it to be destroyed every couple of frames, then call it persistent. Okay, so these are persistent for now. So at the start of our test, we can say naught, the first equals complex factor, yeah? So we're loading the native arrays. I'm calling it iteration because it is just one number. Maybe it should be complex, I don't get confused. Yeah. Okay, I've given them non-plural names, so I remember they're just one. Even though the native arrays with one thing in them. Yeah. So there at the start of every test, it will take whatever's the input on the test object within the editor. Okay, these two things, and apply it to the native array that we have here. These are the native array, the master kind of persistent native arrays that we're going to pass in to the job. All right. Hopefully that makes sense. Just read that manual. It should be good. It's just an example. It's practically the first time I've done it. Invoke delayed. What's going on? Oh, let's go into invoke method. See, I'm lost the minute you lose IntelliSense. I'm done for. So this is job complex factor. Equals complex factor. Does that make sense? So now we're passing it. We're creating a new job, and we're saying that. Oh wow! I didn't call the one inside the job. That's lost me. So this should be a complex iteration. So it's all complex. Back in the job. Okay, so lose all of this. We have created the job. We're not going to use this. Where does this go wrong? I mean, all right, so we've duplicated code because we stripped out complex factor because there's no other way we can do it. All right, we can now use burst compile that we will come to in a minute. We'll try it without burst compile, and then the difference probably, wow. Let's see how that goes. That's gone. All right, so plus counter. Somehow here we've got to add this to a list of jobs. Now this was complicated, all right. It sounds complicated to me. Somewhere in here there's a job scheduling. I'll show you how I'm skipping through this. Job handle, all right. We get a job handle back from all these. There's a static method complete all, all right. If we just sat there and we ran all of these via an invoke, okay, and we did job complete, then what was the point of parallelizing? We didn't parallelize, yeah? Parallelize in the sense that we didn't where does it create the number for those? Sorry, losing it. In the let's strip some of this out because it's just confusing me. All this gone. Start no more. Invoke method, we create these. Complex factor was created here. This is what I'm struggling with. Yes, that. See, we're all learning here. This is the native array float is then described in brackets. I'm looking for the square brackets on the thing, but that's the number of things. If they said N, I would understand it more. It's just me. number of complex iterations, just so we're aware. I'm not sure if you have to have a persistent thing on it. Yes, you do. This is where I don't really know what's going on, because that's not persistent. Okay, this one is not going to be persistent. I've no idea how many frames it's going to be, though. I'll call it persistent. What does none do? What's it? None. No allocation. It needs an allocation, right? Alright, I'll call this persistent. This might be slowing it down. We could probably make it faster without that. Because this one is, it shouldn't be in the invoke method either. This should be in the job. Oh, not the job. See, all the words are getting confused now. But this should be in the start of the invoke test. So it's, you know, so you almost want that there without any. We need a reference to that one. Okay, but now we need, all this is, right, is a handle to all of the jobs during this set of jobs that we're going to run. At the end of it, we could do it here, rather than say no, because, wow, it's getting so fiddly. It would work what I'm about to say, I think. I think if we do like jobs, let's just get the syntax. So job handle, complete all. That's what I'm trying to produce. This is to say that everything's finished. Well, that's like the wait command. That's saying wait until all these jobs are finished. Okay. I'm still thinking about how this is going to lock a thread. It might actually. Because if this is all in the main thread, ignore that. It doesn't matter actually that that's there. Is there a jobs is completed? Jobs handle. Because I don't want to loop all these jobs. Oh wow, see, I'm going to have to read up on some of the complexities. This sounded a bit easier than it could well be. I don't want to sit there and loop through all of them and say they're finished. I just want to use that thing. So I want to say something like if jobs handle all those jobs is finished. I don't want to lock it all up here. Do you see what I mean? Or no, it won't matter because they're multi-threaded jobs. Yes, I think we'll be okay just doing it like this. And then rather than invoke finished, yeah, that never happens. we call that, when all jobs are completed, we can call that here. This might come out not working. Let's see. Okay, so we didn't even call this job. That will measure the time at the end within that. So it's just saying that job handle, complete all the jobs here. Okay, so every time we create a job, which we're going to do in this invoke method. So we're back to here. We're going to, we got plus invoke counter. In fact, we don't want plus anymore because it's now the indexer. So we're saying there's zero based jobs equals job. That's not a job handle yet though, is it? Whoops. So it's not that. It's job handle. See, that's why that is wrong. It sounds wrong. Job handles. Otherwise I'll get confused. Doesn't even like that. What's up with that? It's not assigned yet. Alright, so let's find out what's going on there. What was that job? It had one. Let's see it. Man, I like the I don't know where it's gone, the other manual. The manual with the nice black and, you know, not this bit. Yeah, here we go. Okay, so job schedule. Alright. Straight out the book. Job handle equals job.schedule. So that is taking this job and scheduling it. Okay, I think this might work. There's an ounce of chance. I often throw things together and we just test it. Alright, let's see if it works. The invoke, let's walk it through. Invoke test creates it, gets the stopwatch going. As these two things, job handles, yeah, that's the joy of them being read-only, these things. Inside the, when we set those inside the job, here, because these are read-only, they can all use the same one in parallel. They're completely not locked because they're read-only. That's why they're read-only, so we can pass the same set of instructions to each of the jobs, and they can read them in parallel because they're only reading them, and it knows because they're read-only. So that's the joy of that. And it's going to schedule that job and give us a job handle, and then at the end of the invoke test, it's going to say all those job handles are complete, finished. Yeah. Let's hope it all works. I should do it 10 in case it blows up my computer for a year. Oh, it doesn't like it. Oh god, here we go. Oh, who put that there? Wow, missed that bit. Okay, let's go here. Let's try it again. There's more. Who was it? Let's have a look. It's okay. It's compiled. All right, that was it. Leak detected. Bloody hell. Persistent allocates 2 individual allocations. Wow, let's get the preferences out. Where is the preferences? I never get the preferences out, so Let's have a look on the other page. Jobs. Let's give us more information. I mean, that's it. Do you know what? I don't understand enough about it at this point in time to even fully tell you what happened there. I'm going to run it and maybe it will leak, alright? Blimey, governor. No, but then we got all the errors. Fail out of range error. Job handles 997. So maybe this persistent allocated means what it says, and we couldn't change it. Let's call it temp job. Maybe we should get the book out. I think it was this one. These kind of stay as they were. These are only ever one and they are genuinely persistent forever. This one could be changing. Alright, because this changes every time. I haven't broken my computer forever. No, let's have a look. Do you prefer that? Found one leaky job here. Man, I'm so dumb, I don't get this at all. Why did I delete start? That's where I went wrong. That's where I went wrong, definitely. No, I wanted this to be that. Classic how not to do it, right? Really fed up now. Okay, let's try it anyway. Okay, all those errors? Yes. What it's saying is that invoke counter equals job handle. It didn't create enough. Oh, it's too temp now. That's where I'm struggling getting this job handles native array to work in that sense. It's changing the number of iterations. What is up with that? Drives me crazy. So I'm not sure if none even works. It's getting sad, this. I might have to take a while on the books to work out what's up with that. Still not like my stuff, that's on errors. You just don't want to watch me pouring through the books for hours, trying to figure it out from the manual. Might have to produce a part 2 of this. Yeah, it must be something temp job or persistent. Okay. I would have thought persistent was okay. I'm surprised, actually. Maybe I did something else wrong. It should be the default. It's clearing itself on reallocation. I didn't want this test to only be kind of fixed on the start of everything. What a fumble. You can tell this is like the first time I've done this. So it just doesn't like it. What's up with that? It's not letting me allocate a native array like that. Ton errors. Wait for it. There they all are. I've used the wrong variable name. That's what it's suggesting. Isn't it? Yeah, it thinks I declared it as a 1. Oh wow, that is so dumb. That is so dumb. It's not that number. That's not making jokes about anything. There's that missed big time. It's the human error that you get with the stream. That's what it's about. It was the repeat number, of course. Yeah, that was just genuine error. That should be the repeat number. Okay. That will work now. What a fumble. That was like, oh my god. This stuff's so new. Let's have a look. That was just genuine bug, human error, call it. Misunderstanding of myself. Wait for it. Here we go. This should work. I reckon this will just work now. It's giving me all these errors though still. I think there's certainly a lot of stuff I don't understand, but I don't think it's going to give me the errors. Did that work? Could it be that quick? No, it doesn't make sense. That doesn't make sense actually, because they could not have been all done. I think we have to use this actually from there and not here. And we have to put this in invoke finished, if I thought about it. We have to complete the job handles here. So it's still got the counter. So it's still done. It's created the job. Alright. It was possibly looking at a load of non-created jobs, saying, are they all complete? I don't think it was that fast. And you got to have the 500 milliseconds for the delay, or it just never did it. So that's all compiled in. Yeah. Okay. That's quicker than in just invoke, definitely. I ruined that test. I could recreate it or look at the old videos, but I know from memory that's definitely quicker. Yeah, I think, was it? No. That's a bit of a statement, actually. I think if I look back, that's maybe slower. Oh, wow, I should have this rigged up. I'm so dense. Let's increase the math then. I know that this was like the one that froze up. This is about the time scale that freezes, freezes up the previous invoke. I errored also. Why did it go up to 1499? How did that happen? How did it go so high? He's saying that he created a job that high because we put plus plus. Oh God, am I stupid? I'm starting to worry about myself now. It's getting late in the day. I'm going to knock it on the head soon. Let's re-import that. Okay, so yeah, I just overloaded these. I think those numbers, if my memory serves me correctly, I'd have to get the old video out, or I'd have to rig up the old invoke test and look at it, but I can just look at the past videos. We can say that for this kind of thing, actually that is a bit of overhead. That's like the 30. Task even work anymore. Task was like 69. I think from memory that the invoke is the invoke time. So these things start almost without time. There's almost no startup. Yeah. There's no startup overhead almost. But there is a bit of completion. It says 10,000 of them. Yes, there we go. Do you know what? That's in the park. Do you know what that is almost identical to? 10,000 iterations of the complex math with 10,000 repeats. That number is very similar to tasks. Yeah, actually tasks, what have I done to tasks? Yeah, can you see 11? But tasks has a bit more overhead to begin with. The initialization of the task takes longer. And obviously, can you see this number's a bit random, based around 1,000-ish. What we're seeing there is the jobs. With the invoke, doesn't have the initial overhead. Yeah. That's very similar initial overhead to the invoke, probably just the invoke. It's almost like those the jobs are setting themselves up almost immediately. But you can see the completion of the math is totally in line with the tasks. Yeah. Given the complexity and the repeat number. Yeah, it's completely in line. But how do we put burst compile? How do we put burst compile onto it? Let's get our burst compile out. Burst compile goes right on the top of the struct. So this is our job struct. This one. It's going to burst compile now, and just lightning is going to come out of the screen and just explode. Here it goes. Let's check it out. See, the interestingly, without that, job's very in line with the task, except the overhead. So it's got a test. Except in the, I'm not even sure what I'm saying. I haven't started it. I'm trying to think how to demonstrate that with a smaller amount of math, the less overhead is better. Yeah, obviously the task that with less complex iterations, the job doesn't have the issues. There's an outside chance that this number was actually sub 500 somehow, or coming in very close to 500 with just invoke. Okay, so that is a bit of overhead, but compare it to the overhead on tasks. You can see it has less overhead than a task. It's 10 iterations of the math. I mean, the more I expand that number, the less you notice the overhead, and you'll see the time of the actual. Wow, can you see what's happening? This is at 10,000. Task's still close to 1,000. Look, burst jobs. It's practically doing it instantly. Can you see that? Let's do it again. So what's happening is 10,000 without the burst. But that's like a microsecond. That's not a difference of a half, because there's a baseline of 500 for the delays. Okay, so that's like 495 versus 63 tops. That's how much quicker it is with burst. It's miles quicker. You might see that if I did a massive number. I don't want to freeze this box up forever. Let's do like 25k, 25,000. So we're expecting 3615 tasks, right? That was tasks. Tell me I'm not making it do stupid stuff in the update. Tell me I'm not making the task do this weird thing. Yes, I am still forcing tasks to do that stuff from the previous demonstration. Let's have a look. Recompile, yeah. Tasks did have a bit of overhead that I added to it from the previous thing. That Complexio, the math thing, was actually doing things with the main thread as well. So this is raw. This is raw. It's the same, but it would have added up. No, it wouldn't have added up. This would have made no difference because it was actually only per call. All right, it didn't. That wasn't inside the iteration. So where it really becomes apparent, is about 10,000. So math's got a bit heavy, and where they were identical without the burst, they're now not identical. And let's take this out of 50 then. Let's see how long it takes for the tasks. Yeah, see, that's actually locked out on the math now. It's taking ages. I'm really worried. I hope it doesn't take too long. 15 seconds total. All right, this is burst jobs. 2.8 seconds. See, because the half millisecond is the delay. The half a millisecond, the half a second, the 500 milliseconds was delay. Yeah, so that's the difference between burst and not burst. Because actually, it looks like the actual running, I think, yeah, sorry to confuse everyone. That's the difference, yeah, that's the difference between burst and not burst. But look, if I put this down to 1, this is the difference in overhead. 50,000 repeats. Well, that's quite a bit. Can you see? The more repeats there are, the repeat number is overhead. Yeah, so there's the 500 milliseconds base each case. There's 2 seconds in creating 50,000 tasks, essentially, and 140 milliseconds to create and 250 to perform and exit a task. That's the task handling time, almost purely. The number of complex iterations. Don't blow up for press 0. Will it blow up? I hope not. No, this is not doing any math. This is going to the Complexio loop. That's Complexio loop. It's less than 0, so it's not doing anything. All right. And the same goes for the job. It's not doing anything. There's no iteration there. So at 0 into it, there's no math. This is pure overhead on 50,000. I think tasks been out of control as well. I think tasks really stack up with large numbers. Well, that seemed kind of linear. That seemed like 50. That seemed double. This is 100,000 jobs farmed out. Okay, that jumped because I think it was 500, so it's 600 and something, went up to 846, which is 300 and something. I mean, think of these numbers minus 500 for the base delay. What's 200,000? This is pure overhead, these numbers. There's no, just to create a task and run it, 200,000 tasks. This is the overhead. 10 seconds and 477 to create. Yeah, because the 500 millisecond delay is becoming negligible. So take 500 off that. That's saying 653. It does look kind of linear, actually, throughout the expansion of these things. Honestly, I put in 1 million tasks once and I felt it blew up, but it possibly didn't. You could experiment with this, but it would just take ages. More than 10 seconds is a long time of this. But you can see the jobs does not have the overhead. And some of that is the invoke. The invoke's running the delay, followed by the job. But the job, we're not testing the job's delay mechanism, which exists on batch schedule thing. That is beyond the scope of this at the moment. So this is an invoke also, but the invoke overhead is negligible. Practically doesn't, there's barely any. Maybe there is at 200,000, so it's hard to split the job. That's not like a job from that. We could do them both without delays, couldn't we? Because we're basically testing thread creations. We could take that invoke method. We don't do this, we do this. Alright. So we just go straight to invoke method without an invoke delay, i.e. just straight to a method. We're just calling that method. Right? There's no unity invoke involved. So that sounds stupid, doesn't it? But anyway, and this one's running the jobs. So it's just straight to the job. Okay, and the task test, we go to the task method and we remove, delay, although delay is our entire thing. Oh wow, this is too much. So we avoid that actually, and we just do this await the task run complexio. Okay, so there's no delay in that now. All right, this now is without any delay mechanism and technically without any actual invokes. When it says invoke now, there is no invoke, it's purely the jobs. So this will allow us to look at the overhead of tasks versus the overhead of jobs. With 0 iterations, there's no math happening. You see 10,000, there's no math. That's the overhead of tasks. That's the overhead of jobs. That is the difference totally. Without the burst, jobs 1, if you looked at it, probably because of that, it became really not apparent with a load of math because it swamped this delay time. What's that? 100,000 tasks. That's the overhead. 100,000 jobs, that's the overhead. So we can see jobs are much quicker, okay, without the burst. I don't think burst is helping you at all there. Burst is not speeding up your overhead of the job system versus overhead of that's totally optimized. That's way better than tasks. And then let's go down a notch to where it's kind of negligible almost compared to the task. Oh, hold on. What's happening? Must have said all this. Well, oh no. Well, there's a quirky invoke initialization somehow. 10,000 is not so obvious. 100,000, that was really apparent. That's what I think tasks kind of spiral out. Around that level. Difference between 10 and 100,000, there's no delay there. That massively span out. You know, the difference between 1,000 tasks, 6 to 60, is it that tasks are linear? At 60 to 100. But that would make this number 1,000 with another 0. What I'm saying is that really span out. Yeah, to 5,000 from 100. It didn't go 10 times 100. It went 55 times 100 as we went to 100,000. I think that's why if you go to 1,000,000, let's just give it 500,000 and see what happens. This could blow up. I mean, I think the task system has a limit to its handling. This is like C# task handling. How long is that going to take? It would be 25 seconds, maybe 30 seconds if it was totally linear. But it's not. I think it's actually going to blow up. And that's why I've not been doing that above that level, because it takes ages to create that many tasks. Yeah, and complete them. It's not doing anything. There's no complex iterations. There's no math involved. That's purely the task handling, setting up and destroying a task thread. Yeah, that's C# task handling, kind of exploding on large numbers at once. I can wait. It might be boring. We could look at some code, but yeah, it's not linear. It's been 30 seconds at least. That is totally. It might be exponential. It might be going into a zillion seconds at this point. I don't know. I'm going to kill it. I mean, we could test with 200 and stuff. I don't know where to kill it either. I'd have to kill Unity. The code's all saved. That's the issue. A task blow up. I mean, we can see how many jobs blow it up. Is it still not finished? Okay. Yeah. I'm coming back in 1 minute. Just wait a minute. Yeah, sorry about that. That's getting like a real stream, just letting you sit there whilst we, do whatever. Let's. I'll probably wrap this up quite quickly. I think the take home there is that tasks in smaller numbers are relatively similar in terms of performance of threads. Particularly with a large number of math. Yeah, if it was like a large number of iterations, then task threads without burst are similar. With burst, it's no comparison. The burst is way, way quicker. Jobs have destroyed tasks in that way. Where were it? It's like 100,000 you can do 100,000 tasks. And that was like 5 seconds or something, was it? Yeah, 5.6 seconds. Above that, 200 worked. I think there's a limit to the task system. This is jobs. Wow, jobs are just... Hold on, that number's random. What's up with my jobs? That is jobs at that 100,000, 10,000 jobs. Yeah, that's more like it. Yeah, jobs are very linear. 100, 30 seconds, 100,000. That's so weird. 200. Yeah, no, 300 milliseconds. Very linear. Let's see if we can do the two. Let's do 500 and see if it blows up. No, it didn't. It did not blow up. It did linearly expand to 1500. It's very linear jobs. Whereas tasks just seem to expand almost exponentially and explode around this level. You can't run tasks because it just took forever. Not 500,000 at the same time, whereas jobs just did that, no problem. Very linearly. The certainly the initializer is the first number. Divide by 10. Yeah. Hold on. That's what's going on there. Sometimes when you press it, one thing's finishing, the other hasn't started. So the second time you press it, it totally makes sense. Yeah, they're very linear, aren't they? It's completing. They're completing with no iteration. The jobs are timeless, right? With no work, they're practically zero. It took the first number is the second number. The second number minus the first number is the time of the jobs. See, if I added iterations, second time around, it makes sense. So I'm adding a bit of math to it. 10,000, it's definitely got work in it. Yeah, there we go. Can you see that? That doesn't actually make sense. It's almost like they're instant. Oh, that's a mad amount of math going on. Yeah, no, I think the second number's going to come through this time. With burst, they're almost instantaneous with a huge amount of... No, there's two numbers on. I want to check that it looked like it was working. How did it look like it was working earlier? Because with 10,000 of these, made more sense earlier. Anyway, there's some really interesting conclusions there. I think they're incredibly faster than the tasks ever are. However, I'm a bit worried now that I've changed it somehow. This is with no delay. It's almost like the jobs are running instantaneously, that amount of math. No, they're coming in quicker sometimes. I'm not massively convinced that I've rigged it up 100%. Anyway, I might wrap it up now. Really check some stuff out. Make sure it's working, because it's almost like they're not doing anything. There was that initial test when they seem to really make sense. Without burst, they made sense. Let's try it without burst. That was the last time it made sense because they weren't instantaneous. Use without the burst. Burst can't make them instant for huge calculations, can it? I think I got lost a bit when I restarted it. I may have broken it. Yeah, I'm not convinced. The second number, it's not very convincing that they've actually finished. Hold on. I think it was something I changed during it. This could be my understanding of it all. Ensures that all jobs automatically first are prioritized, all the given. It doesn't make a lot of sense. I don't think it can be that quick. So it definitely fills up all the job handles. It did everything in that thing. Well, I might have to check this out and come back to it. It's a shame actually, but it's just time running out. But it's really interesting. It made more sense earlier on. Maybe something changed. Yeah, I'm out of steam anyway, so I'm going to come back to this a bit later on, try and work out what happened. But it's looking very good for the job system, I think, to win actually a lot versus task, particularly on the overhead. And then with burst, I seem to have lost the timing of that. So, yeah, I hate conking out when it's not really conclusive, but yeah, I'll possibly come back to this. Thanks for watching. I've got to duck out and do something right now.